Welcome back, everybody, to the fourth and final installment of the Tenon Cutter build series, where I am building a crazy contraption that will cut the long cheeks of tenons really quickly. If you're just joining us, there are 3 videos ahead of this one that detail the overview and fabrication. And in this video, we are going to put it all together and make some sawdust. And we're also going to build a dust collection chute kind of thing and fabricate a blade guard for this horrendously dangerous tool. So the first thing I did once all the paint had dried sufficiently was peel all the masking tape off, which is always satisfying for those nice clean paint lines. And then I also moved on to hammering in the little end caps for the frame. These little plastic caps fit into the square tube. The next step was to start fitting the components. So I started with the bottom of the cross slide sled. All of these things are put together basically finger tight so that I can get the fitment just right and make sure there's good clearance with everything. And then I start to tighten things up and bring them closer and closer together. Same thing with the shaft here. One thing I noticed was these are self-aligning bearings. So at first I thought the bearings were completely broken, but then I realized I just needed to sort of bend the shaft to align the bearing in its cylindrical or its sort of spherical holder. So once the shaft was spinning smoothly and all the bearings were aligned, I checked the drawing and adjusted it to the right length and set the set screws and started putting all the subcomponents on, like the pulleys and the blade holders and making sure all that fit well. Now moving on to the cross slide again. This, as I mentioned in one of the earlier videos, it's not the most high quality item, so there's this weird press fit piece that I had to clamp in there. That went in pretty easily. And then it was a matter of attaching all the original parts and the gibs and getting that to slide smoothly and freely. Once all the parts of the cross slide were together, I attached the hand wheels on their newly machined areas, fit some keys in there, and put in a set screw and a little retaining bolt. Probably overkill to have the set screw and the retaining bolt, but it was nice to have something in there to kind of have a clean look on the front. And then just test fitting and tightening and making sure everything ran smoothly. Now attaching the motor mount to the frame. This is a cool little piece of kit I got from McMaster. It saved me a bunch of time and design work in trying to figure out a way to fabricate my own motor belt tensioner. They sell these stamped steel pieces that have a captive screw in the back, and you can adjust that bolt to tension the motor, raising and lowering it, and mount the motor onto that piece, and then the pulley onto the motor itself, which fit nicely, and the belt. And now I can tension the belt a little bit and fit the motor. There it goes. So I'm getting excited at this point because this is like a machine now. We have a motor, pulley, belt. I added in the retaining screw for the depth adjustment, and then also added in the final install of the table with fence. Bolted that in and then began aligning and testing that fit. And now we put the blade on, and it looks like the blade actually was a little bit too close to the table, so I had to shim the whole cross-slide assembly off the frame. Moving on to fabricating the blade guard, which became, as soon as I put the blade on, it was immediately apparent I needed to put a guard on here, whether it was flinging pieces of wood at my face or leaning on it accidentally and cutting my hand. So this was a little bit of an afterthought from the original design, so I catted that up, printed out a one-to-one drawing of the bent item, and then just hooked up the acetylene and heated up each bend and bent it to match the drawing roughly. I clamped the parts in place to do some test fitting and figure out where the bolt holes were going to go, and kind of bent everything until it looked correct. The other thing that needed to be fabricated was this rod to serve as the depth stop. I had put the acetylene away at this point, so the MapCast torch came out to bend that to a right angle, and then I cut it to fit the length that I needed to go in that little depth stop holder attached to the cross slide. Now that the machine was largely assembled, it hadn't been wired yet, but everything was in place, I thought I might as well add in some sort of dust management system. I didn't really design it in the original concept because I wanted to kind of see where everything was going to lay and where the dust port might go, and it was kind of an afterthought. This tool I was using to build another piece of furniture, so I was kind of rushed to get this tool finished, and so I was tired of just sitting on the computer all day. I wanted to start building this. But, that's okay. So basically I'm fitting some thin pieces of plywood to make a little triangular chute that sits below the blade, and a little dust port that attaches to that. By this point, the paint had dried on the blade guard, so I installed the blade and then bolted on the guard itself. In order to get the dust collector chute in there, I had to remove the motor, so I had to pull the motor off again and retension it and get everything to clear just right. This is obviously an exact example of why you do everything in CAD first, because this motor was just touching the dust thing when it was untensioned, so it was a very sort of tenuous situation to get it all in there, and that I would have seen it impact if I had done it up in CAD. Moving on to the electrical, I got a pretty inexpensive motor switch off of Amazon, which seems to not fit any of the American electrical boxes. So I started mounting that. It was at this point that I realized that I needed to get this thing off my bench because it was heavier than I could awkwardly lift. It's a little over 100 and something pounds and kind of weird and bulky. So I strapped it up to a come-along and lowered it down and used the come-along as an opportunity to fit the feet, which hammer into the bottom of the legs and then get screwed in there. And they're these rubberized, flexible, leveling feet that I can make sure that the thing is completely level to whatever surface it's on. All right, back to the electrical work. Nothing complicated here. I was wiring it in 220 mode. Just connecting the right wires to the right patch wires inside the box on the motor, and installing some strain relief on the cables, and then routing that to the top of the switch mount box, and then routing a power cable and assembling that to the bottom. As I was saying earlier, this switch was rather bulky for the box I got, and the screws didn't really line up. I had to drill some extra holes and really be careful getting the wires in there because there was almost no room in this box to make the wires route. So the price was right, but I ended up sort of putting a lot of time into getting this switch to mount on this type of box. I think if I use this switch again for another tool, I'm just gonna modify an off-the-shelf enclosure or build in some sort of enclosure as part of the tool itself. Always a little nerve-wracking to start up the first time. I think this was the actual first time I started it, so I'm pretty stoked about that. Last step, put a little grease in the pillow block bearings. Get it ready for some real cutting action. Just finished the tenon cutter. I have my fence set, the amount I want to remove, and I have the table set half the thickness of the material, and I have a depth stop set for how deep it goes. So let's see how easy it is to cut some tenons. I'm pretty happy with that. I need to probably check everything for square and calibrate it, but it runs really well. The camera's sitting on it on just a little phone stand, so very little vibration. Awesome. And there we go. We have a completed tenon cutter, and I immediately used it to build a crib and a changing table, which I have a build video on that, either 2 videos or maybe 1 coming up. This was a very satisfying tool to build. It's amazing the efficiency this adds to your workflow process. You can see what's happening right now. I'm just crushing through all these different tenons. Makes it very easy. So really appreciate all the viewers that have watched this, and please subscribe and check us out on Patreon, where I will post my shop drawings, and the plans for this will be available on my website. So thanks again, and we will see you next time. Thanks everybody for watching. If you found this content helpful, please consider supporting Never Stop Building. The easiest way to do that is to simply hit that red subscribe button and click the bell to get notified of new videos and content that I release. If you really want to be my best buddy, become a Patreon subscriber, where you can get plans to all these projects, exclusive content, and much more. So check the description below for a link to that. And as always, never stop building.